Good day guys, today I want to do a little roundup of all the screen technologies I have lying around and how you can use them in your projects. I'm going to be looking at how many wires they take up on the board, how they perform and which data is perhaps best displayed on what screen type. So without further ado, let's dive right in. We're going to be using Arduinos. We're going to be using the ESP8266, which is a little bit more powerful than Arduino and has built-in Wi-Fi. And I tried to get the STM32 to work, but there were some issues that I'm still working out, so that is something for a future video perhaps. I do realize that I also forgot an OLED screen, but I don't have those lying around, so you owe me that one as well. Now, to get started with our roundup, I'm going to be using the cheap 7-segment display of AliExpress. I just want to see how it stacks up compared to the proper one I've sourced from a local retailer, and see if we can actually see a difference in performance and the way it displays the data, like the changing of the values. Now I've gone with the same approach for almost all of the setups, and that's that I've hooked up a potentiometer to my Arduino, and the screen will just display the value that it's reading currently. And that's just because we can turn it fastly, we can turn it slowly, and we can actually see the difference between both and how all screens behave in that situation, right? So we're going to start with the cheap one and we're going to work our way up until the more advanced ones that we have in there. Now the beauty of these 7-segment displays is that they only take 4 wires. And even that is a bit of a lie because it requires a ground and power line. But these are usually just common lines, so we can just hook them up to our breadboards, and we can connect them then with just hooking up 2 wires to the board. It makes use of quite some easy to use libraries. I forgot to actually set this one up in code, and I've got this up and running in like 2-3 minutes. So that's the ease of use of one of these displays, and that's the beauty of it. As we're able to tell, here is our potentiometer, and just hooked up to our board, and it's just gonna pass the value to the screen. So let's just get started, shall we? Okay, so we finally got it hooked up. I had some issues with, I took one of the broken ones. So if we change the values, we're able to tell it actually changes quite smoothly. There's a bit of jitter on the line, and that is why, this one is jumping around like crazy. And this is a very cheap potentiometer as well. But as we're able to tell, it works fine. Data changes quite rapidly, and that's important. Like if you use this for altimeter, airspeed, etc., those values change on a quite high pace, right? And that's why you want your display to actually refresh at a high rate as well. Now this is the really cheap one from AliExpress. I believe it was like 80 cents a piece. So all in all, for 80 cents, this is, I couldn't wish for more. They're quite huge. Let me put the other one in comparison to this is what you usually get as a, as a 7-segment display. So the size difference is very noticeable. You have the option to add a dot in between each value and a double dot in the middle for a clock. I'm going to hook up this one as well, because that's the beauty of these things. They use the same architecture, and I just am curious if this one works better. Now, like I mentioned, this is way smaller, but I do have a feeling it's a bit more appealing to look at, but that could also just be me. Yeah, I think it's actually, I don't see the difference. Do I? Yeah, perhaps the flickering is a little bit less, or less noticeable if it happens. Look, if we change it fastly, it can keep up. Let's refocus. Yeah. So all in all, there is a difference. If the other one was 80 cents, I'm not quite sure if I would recommend getting this one, right? The only thing that to think about this one is that it's smaller, but I think you have these one in smaller as well on AliExpress. So all in all, it works better than I expected actually. I thought this one would be way worse than this one. So let's put the other one back again. And now people, I always say don't change things when it's live, like when the power is on. But for you guys, I'm willing to take that risk. Just to, you know, ease of the video. The difference, I believe, what makes it look a bit less smooth is the size, you know? Because it's bigger, it actually is more apparent when something is flickering, because it's huge, you know? So all in all, I would say performance-wise, equal. They both pass the test. Now, I would use this for, let's say, something frequency, altitude, speed, etc. Well, frequency depends on what kind of setup you have. You have to do something like with 2 of them and find a way to code that it displays 123.4.567, etc. So that's something to just programmatically overcome. So I like this one and I like this one, and I'd recommend both. Okay, so next up are our old school. I still love them to debug stuff, displays information as well. Of course, I'm talking about our LCD screens. Now, we have several sizes. I have one in my test rig that has 4 rows and I believe 20 characters, 26. And we have the old school ones, the 2 rows and 16 characters, I believe. Now, there are 2 versions available for these as well. We have the I2C ones. You can either buy a normal one like this and hook up an I2C interface to bring down, what is it, like 16 pins needed to only 2. So I'd highly recommend the I2C ones because it just saves you so much space on your Arduino boards. You know, it saves you so much headache when you mess up. I've had it many times that I thought everything was wired up perfectly and then the screen would work or something else, and then I would start debugging, etc. So I2C is, in my opinion, the way to go, and they aren't that expensive. Now, there is a small issue though. Normally I buy my LCD screens with the I2C attached already, but all these didn't come with I2Cs, so I bought the wrong ones and I thought I'd solder on them myself, but I did it in the beginning when my soldering skills were terrible, and I've used like soldering paste for plumbing and they're all ruined. So this one doesn't work, this one doesn't work, and I'm not quite sure what I did with this one. But this one isn't gonna work as well. But no worries, we're just gonna grab one of the test benches and gonna use that for the test. So this is our LCD hooked up. It's really easy to program. Now the bottom value is the potentiometer, and if we start rotating, we can see the value change. Now, I do have to admit that the 7-segment display, the changing of the number actually was a bit more clearer while it was changing what it was, right? Because right now it gets a bit fuzzy until we release and then the proper value is displayed. And like I said, if we go to 1023, yeah, it's a bit tripping. I think some wiring is messed up. But if we go down, you see the 3 stays there no matter what, because it's only a 3 number value instead of a 4 number. So this one doesn't get overwritten unless we specifically tell it to add a space in the end. So all in all, it's really easy to program with this. We get the freedom to, you know, utilize quite some space. It are predefined spots you can work in, so it isn't like free form like a TFT screen or an OLED screen. But all in all, for the cost and the functionality to quickly display a good amount of data, I highly recommend this. I use this for the comps, for instance, that don't change that often, you know, 123.457. And if you switch, it's going to switch itself over, and it gives you a good representation of the value in there without changing too much. Because if you want a value that changes on a high pace, like altitude or speed, this perhaps isn't the ideal solution because it just becomes one big of a blurry mess. If you want static information, I'd highly recommend it because of the ease of use. Now, like I said, these ones use 4 pins and the other ones use 16 pins. Please go with the 4-pin version, the I2C one, and it's so easy to hook up and program that even if it's €1 more or $1, it's going to save you a headache. So that's the LCD screen. We've been using this in lots of our projects, and I will be using this in the future as well. Now, we also have a newcomer that I haven't used previously. I had just laying around in a drawer. I hate that word, but I'm starting to love it, and I'm going to show you why. So the last ones in our roundup are going to be the TFT screens. Now, I know that I skipped the OLED screens, and I just realized when I was recording that I haven't got one of those yet. So I'm going to buy one of those and keep you informed on how they perform. Right now, we're going to be talking about the TFT screens. They make use of around, how many are these? 1, 2, 3, 4, 5, I believe 8 pins. 2, 3, 4, 5, 6, 7, 8, 9. This one uses 9 pins, this one uses 8. It's a big bit of a size difference. The only thing is though that these require quite some force to be driven, especially this one, because it's like, this is 128 by 160 and this one is 480 by 320. And this one is going to max out our Arduino. And this is the point where I'd recommend to get rid of the Arduino if you want to use one of these and start to get something more powerful. Now, I'm going to show you the ESP8266 because that's one that is cheap and can be easily used with an Arduino. Perhaps a Teensy can be used as well. They are a bit more powerful. They're a bit more expensive though. The ESP8266 cost around 4 or 5 euros and they perform amazingly with these screens. Only downside is they have less I/O. Okay, so besides the smaller one, we also have a quite larger one, as you might be able to tell. See, I think it's like 4 times the size. 1, 2, 3, 4. Yeah, something like it. Now, I've got this hooked up to an Arduino Mega. It requires quite some wires, but just one more as the smaller one. Let me see, and they need to be in specific pins as well, because they use the hardware SPI, which is kind of, how can I explain this? It's a bit like, we've used I2C before. Well, hardware SPI works, it doesn't work the same, but it's the same. It's also a protocol to, hook up devices, get some addresses, because I could hook up this one to those pins, and I could hook up this one to those pins at the same time as well. And then they just have different addresses, etc. So that's something to look out for. I will put a link to how hardware SPI works, etc. in the comments down below, so you can read up to it for yourself. It was a bit of a pain to get this one to stand up, so I put it on my crocodile clamps. This is the point where I would say our Arduino just doesn't cut it anymore. Because look what happens if I change anything. I've got my potentiometer hooked up to the Mega, and it displays in a bar how far it's open or how far it's closed, and it changes the value. But you might see the Arduino Mega just doesn't have the power to really drive this big of a screen, and it just gets laggy as can be. See, I closed it. It needs to draw everything. You can even tell it if we reset it. Let's see. Look how slow it's gonna draw. It's just gonna fill the screen with black, but it takes ages, And this is the point where I would say get rid of the Arduino. Oh, I'm sorry. Because if we have a stronger microprocessor, this problem can be eliminated. So that's something we're gonna do. I'm gonna hook this up to our ESP8266, which is this board. This also has built-in Wi-Fi capabilities. So my sub counter is this one. It displays how many subscribers I have on YouTube, but I only have to power it. It doesn't have to be connected to my computer via serial. As long as it has power, it can receive the data, and that's because it has a Wi-Fi chip. So this one connects to the internet, scrapes the YouTube API, gets the subscribers, and displays it on the screen. So that's the beauty of an ESP8266. It has the Wi-Fi chip built in, and it's way more powerful than an Arduino could be, and they're actually quite cheap. I believe I bought these for like 4 euros. Another option would be to go with the where is it? Here we go. Here it is. STM32. Am I correct? Yeah. I haven't got this to work yet, so I still need to figure out how exactly this worked because, yeah, I don't know if this one is broken or there's something else in play. I just do stupid stuff. I need to find it out, but that's also an option. But 8266 is something that we can run from our Arduino environment, so that's something we are familiar with. Okay, so now things start to get interesting. Now, the downside of an ESP8266 is that it has quite limited pins of it. I'm gonna do a close-up later when I have this disconnected, but it has fewer pins to hook up I/O in, so inputs, outputs, LEDs, etc. So this LCD is already taken up almost all of the pins on the board as it is. So, but the results, let's see how it looks in action. It's the same code running on a different device. Oh, I pull out the potentiometer. But as we're able to tell, it's you can actually see the transition. The numbers are way more clearer. The changes aren't as obvious as it was before. Well, you can see change, but not the black, white, because it does the same thing, right? Because you got to see it as every pixel gets drawn on. So if I change this one, it needs to cover up the previous one, like here. It covers up the yellow with black, and if I go the other way around, it covers up the black with the yellow. So it's really drawing on top of things. So if you want to change this 7 to a 1, you have to make the other pixels black again. So it's kind of like drawing. If you want a new number, you have to first even out the background and then put in the new number. It's just the same as in the previous video, like, with the Mega. It's the same as the Mega. You could really see that happening. You could see the numbers change, then it went black, then it would change, then it went black, then it would change, etc, etc, etc. Same goes for here. If we move fast, we can see that actually, so you see, it is more accurate than I would. Yeah, it's fine. You know, this is usable. This could be used for anything. I was thinking, like, if we could create a graph on it, which is possible, with our altitude, we could create a little visual representation of our landing slope, right? We could do it like, I don't know. So you're able to tell at which altitude you've descended and what kind of curve you took towards the landing strip. So for something like that, this is actually quite a powerful device. It even has touchscreen capabilities. I haven't hooked it up yet, programmed with it yet, because I wanted to focus mainly on the displays in these videos. So I wouldn't use this for everything. You know, you could also do COM1, COM2, etc. And that should also be fine. I don't know, actually. I love it. It was it's a bit of a learning curve to program this. It's once you've got the right library, it's fine. But up until then, it can be quite a hassle. So I would highly recommend a screen like this, but I would also recommend to get something else in Arduino with it. Perhaps a Teensy would do better as well, because it's also more powerful than the Arduino itself. All in all, I would recommend it. You can create some really cool graphics with it. I just made a little bar that goes up and down based on how far the rotary potentiometer is open. But you could you could even make a speed meter out of this, a digital one where you would have like you have turning around. The sky's the limit with this. So would I recommend it? Yeah. Is it easy to use? Okay. It does require a lot of cables on your board though. So that's something to keep in mind, that if you're already full on a board, that this isn't going to fit in there with just 2 cables. But all in all, I like it. I'm going to test some more. Like I said, I want to do the descending glide and ascending glides to see how that would look on a graph. That's something I'm looking out for. But so this ones I recommend. The smaller ones as well. It's just you don't have much room to play with, because I believe this one is 128 by 160 pixels and this one is 320 by 480 pixels. Yeah, correct. And that's why, because this is like 4 times the pixel amount of this one. I believe something, perhaps even more, I'm not sure. that's why it takes more power to process it. Every pixel needs to get drawn and calculated. And on this one, it takes less power. It also has an SD card reader, because if you want to, use images on it itself, you can just read them directly from the SD card. It's going to make processing this a little bit more easy. So yeah. So all in all, I really like the TFT screens, but they take a little bit more space and they require more workforce, like I said. This is a close-up, I hope, of the ESP8266. Perhaps you're able to tell it has like D0, D1, 2, 3, 4, etc. Let me just count for a second. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 digital inputs and 1 analog input. And that's the downside of this board. It has a really small I/O. Now, like I said, we could also use something like this is a STM32, but I'm having some issues getting this to work with the Arduino environment, because that's something that I prefer. Is an Arduino environment is just really easy to use and get into. And my projects are mainly based on, I want you guys to follow along if you're just starting out with a hobby. And that's why I want it to be easy to work with and not create a new barrier to get started. So I'm gonna work this out to see if there's an easy approach to get this working and to see what the results are with the TFT screens as well. So that was a little roundup of our screen technologies. Some of them are quite basic, some of them are a bit more advanced. It's up to you to see what your project needs, and I hope you have now a more clearer view of what works and how it works and how you can implement it yourself. So if you want to keep updated, subscribe, and if you like this video, like, and I hope to see you in the next one.